An infrared search and track system is a method for detecting and tracking objects which give off infrared radiation such as jet aircraft and helicopters. IRST is a generalized case of forward-looking infrared, that is from forward-looking to all-round situation awareness. Such systems are passive, meaning they do not give out any radiation of their own, unlike radar. This gives them the advantage that they are difficult to detect. However, because the atmosphere attenuates infrared to some extent and because adverse weather can attenuate it also, the range compared to a radar is limited. Angular resolution at short ranges is better than radar due to the shorter wavelength. Early systems, the first use of an IRST system appears to be the F-101 Voodoo, F-102 Delta Dagger and F-106 Delta Dart interceptors. The F-106 had an early IRST mounting replaced in 1963 with a production retractable mount. The IRST was also incorporated into the Vought F-8 Crusader, which allowed passive tracking of heat emissions and was similar to the later Texas Instruments AAA-4 installed on early F-4 Phantoms. The F-4 Phantom had a Texas Instruments AAA-4 infrared seeker under the nose of early production aircraft F-4Bs and F-4Cs and not installed on later F-4Ds due to limited capabilities, but retained the bulge, and indeed some F-4Ds had the IRST receiver retrofitted in a modified form. The F-4E eliminated the AAA-4 IRST bulge and received an internal gun mount which took up the area under the nose. The F-4J also eliminated the AAA-4 IRST receiver and bulge under the nose. The Swedish Saab J35 F2 Draken also used an IRST, a Hughes Aircraft Company N71. Technology. These were fairly simple systems consisting of an infrared sensor with a horizontally rotating shutter in front of it. The shutter was slaved to a display under the main interception radar display in the cockpit. Any IR light falling on the sensor would generate a pip on the display, in a fashion similar to the B-scopes used on early radars. The display was primarily intended to allow the radar operator to manually turn the radar to the approximate angle of the target, in an era when radar systems had to be locked on by hand. The system was considered to be of limited utility, and with the introduction of more automated radars they disappeared from fighter designs for some time. Later systems, IRST systems reappeared on more modern designs starting in the 1980s with the introduction of 2D sensors, which cued both horizontal and vertical angle. Sensitivities were also greatly improved, leading to better resolution and range. In more recent years, new systems have entered the market. In 2015, Northrop Grumman introduced its OpenPod, TM, IRST pod, which uses a sensor by Selects ES. The best-known users of modern IRST systems are Russia, Su-27 Flanker, Mikoyan MiG-29, Sukhoi PAK-4. United States, Grumman F-14 Tomcat, Lockheed Martin F-16EF Block 60/62, Boeing FF Super Hornet, Lockheed Martin F-35 Lightning II-A and AAQ-37 electro-optical distributed aperture system with a 360-degree IRST, missile detection warning, and day-night vision capabilities, designed and produced by Northrop Grumman Electronic Systems. Sweden, Saab JAS-39 Gripen EF. United Kingdom/Germany/Italy/Spain, Eurofighter Typhoon. France, Dassault Rafale. These aircraft carry the IRST systems for use in lieu of their radars when the situation warrants it, such as when shadowing other aircraft or under the control of Airborne Early Warning and Control, AWACS, aircraft or ground-controlled interception, GCI, where an external radar is being used to help vector them onto a target and the IRST is used to pick up and track the target once they are in range. With infrared homing or fire-and-forget missiles, the aircraft may be able to fire upon the targets without having to turn their radar sets in at all. Otherwise, they can turn the radar on and achieve a lock immediately before firing if desired. They could also close to within cannon range and engage that way. Whether or not they use their radar, the IRST system can still allow them to launch a surprise attack. An IRST system may also have a regular magnified optical sight slaved to it, to help the IRST-equipped aircraft identify the target at long range. As opposed to an ordinary forward-looking infrared system, an IRST system will actually scan the space around the aircraft similarly to the way in which mechanically steered radars work. The exception to the scanning technique is the F-35 JSF-STAS, which stares in all directions simultaneously, and automatically detects and declares aircraft and missiles in all directions, without a limit to the number of targets simultaneously tracked. When they find one or more potential targets, they will alert the pilot, and display the location of each target relative to the aircraft on a screen, much like a radar. Again, similarly to the way a radar works, the operator can tell the IRST to track a particular target of interest, once it has been identified, or scan in a particular direction if a target is believed to be there. IRST systems can incorporate laser rangefinders in order to provide full fire control solutions for cannon fire or launching missiles. The combination of an atmospheric propagation model, the apparent surface of the target, and target motion analysis, IRST can calculate the range. Performance. Detection range varies with clouds, altitude, air temperature, target's attitude, target speed. The higher the altitude, the less dense the atmosphere and the less infrared radiation it absorbs, especially at longer wavelengths. The effective reduction in friction between air and aircraft does not compensate the better transmission of infrared radiation. Therefore, infrared detection ranges are longer at high altitudes. At high altitudes, temperatures range from 30 to 50 degrees Celsius, which provide better contrast between aircraft temperature and background temperature. The Eurofighter Typhoon's Pirate IRST can detect subsonic fighters from 50 km from front and 90 km from rear, the larger value being the consequence of directly observing the engine exhaust, with an even greater increase being possible if the target uses afterburners. The range at which a target can be sufficiently confidently identified to decide on weapon release is significantly inferior to the detection range. Manufacturers have claimed it is about 65% of detection range. See also, Electro-Optical Targeting System, ANAAQ-37 Electro-Optical Distributed Aperture System. References. Notes Citations Bibliography Eden, Paul ed. The Encyclopedia of Modern Military Aircraft. London, Amber Books Limited, 2004. ISBN 1-904687-84-9, Kinsey, Bert. F-106 Delta Dart, in detail and scale. Fallbrook, California, Aero Publishers, 1983. ISBN 0-8168-5027-5. Sweetman, Bill and Bonds, Ray. The Great Book of Modern Warplanes. New York, Crown Publishers, 1987. ISBN 0-517-63367-1. External links, Fraunhofer Institute IAF Annual Report 2006 German and English.